working as assistant professor in the Department of Mechanical Engineering, SNS College of Technology. So in the lecture series, we are going to discuss about the steam power cycles. So in steam power cycles, especially we are going to discuss about the ideal Rankine cycle. So now let's, before going to the topic, let's have some recall. Okay. So generally, where the steam power cycles is used. So normally in thermal power plants, we are using steam power cycles. So here in this thermal power plant, normally what the cycle we are using is, we are using the Rankine cycle. So this Rankine cycle was introduced by the engineer William. So here, what is the basic principle in the Rankine cycle is, so the heat energy is converted into mechanical energy. And then here, the working system is a closed loop system. So whereas the water which is supplied, which is converted into steam, is again reused. And then here, the energy which is produced here, we are using approximately 90% of the energy is used to the globally in our day-to-day lives. So before going to the topic, let's have some empathy. Okay. So here we are having some empathy. So generally, before going to the thermal power plant, we will see what is the existing problems in the hydroelectric power plant. So power generation is made through hydroelectric power plants, thermal power plants. But in hydroelectric power plants, water is used as a medium. Okay. But this water is used as a medium has to be stored so that long dams, and then the cost construction of the dams is very high. And second one is, because of these dams, what happens is sometimes flood may be occurring. So at that time the water cannot be stored; it has to be released. So here flooding can be taking place. And as we discussed earlier, so it takes more time to construct dams because it's a very big structures. So the cost is also very high. And then we are coming to the efficiency. When we compare to the other power plants, the efficiency low in case of hydroelectric power plants. So based on this empathy, we are defining a solution that ideal Rankine cycle we are taking as an defined. So what is the basic in the ideal Rankine cycle? Okay. Here what are the components is used is, here there is a boiler, here there is a turbine, here there is a condenser, here there is a pump. Okay. So what happens here is, here heat is supplied in the boiler. So when heat is supplied, what happens is, the water which is passing through the boiler is converted into steam. Okay. This steam comes to the turbine, and what happens is, the expansion process takes place in the turbine. So after turbine, here the output is work. Work is extracted from the steam. So after that, the steam which is passing here, the heat is rejected and is converted into water in the condenser. And then again the water is coming to the pump and the water is supplied to the boiler. So this is a closed flow system. Okay. So here what happens is, the input is given as the heat and then the output is the work done. So this is the basic principle in the ideal Rankine cycle. So let us discuss how this what is the idea and how it is to be worked. Okay. So here, what are the major components is, first we are taking hot well. Okay. So this hot well is used to store the water. So here there are many processes. The first process is, we will start from here. Here the 1 to 2. Okay. When here it is entering as a fluid, it is entering as a water. So here what happens is, when the water comes to the boiler, high heat is supplied with the fuel which is burnt. So when the fuel is burnt, this water is converted into wet steam and then dry steam and superheated steam. So this superheated steam, what happens is, comes to the turbine here. So here in the turbine, what happens is, work is extracted and the work is taken outside. So now coming here, the water which is coming to the condenser, heat is rejected outside, so that what happens is, again it is coming as a water at the point 4 here. So now by using an extraction pump, what happens is, water is stored in the well and then again this process continuously made. So this process is explained in the TS diagram. So this is the y-axis, it is the temperature, and here it is the volume and entropy. It can be taken. This is the dry saturation curve where this part locates water. Here it is wet stream, and on the line it is dry stream, and then this area is superheated steam. So here the process 1 to 2 is in the pump. So when it is pumped, the temperature is increased, and then here heat addition takes place, and then expansion takes place, and then here compression heat is rejected. Like this, many processes are combined together.